Hello, everybody. I think we are going to start again this new session. So my name is Jacques Majin. I'm working in the Amplifier project, and I'm really excited to co-moderate this session with Paulo Marques, who is here. I think this is probably we've been working for some time on trying to think about the interaction between fire and 5G in general, and I think this is a first opportunity to discuss that with such a numerous audience. So please, this session is not only for the panel to discuss, but also for you to interact, to ask questions, and to bring ideas. This is why, if you have questions after each of the presentation, we would prefer here that you just ask these questions. We can keep, of course, some questions at the end, but do not hesitate. If you want to exchange and interact with the panel after each of the presentations that are given, please do it. So I am extremely happy to welcome this panel. So we are going to start. Okay, if I can find the right. Okay, here it is. So we are going to start with Paulo Marques, who is going to talk about 5G demands and requirements regarding testbed facilities. Paulo received his PhD from University of Aveiro in Portugal in 2006. He is a senior researcher at Instituto de Telecomunicações. He was the scientific coordinator of the FP7 COGEU project during 2010-2012, and he is currently the scientific coordinator of the CRSI project, which means Cognitive Radio Standardization Initiative. As part of this work, he has taken up chairmanship of the European Commission Radio Access and Spectrum (RAS) cluster projects under Objective 1.1 Future Networks. Paulo, the floor is yours.
Okay, maybe.
Can you put it on the screen?
Okay. Okay, good morning. Thank you, Jack, for the kind introduction. So I'm an outsider from 5, let's say. I have been participating as an open call once, but my idea here is to present some considerations regarding the possible cooperation between projects that are not in 5 and projects that are working in 5G with 5. So I have been the chairman of the Radio Access and Spectrum Cluster. That is a cluster of more than 20 projects working on radio access and spectrum issues, funded by the European Commission. And the RAS cluster main objectives is to boost the project impact beyond what they can achieve alone and enhance project cooperation in the different areas of radio access and spectrum. So if I pick up the 5G Cube proposed by Docomo, and since you have here Japanese colleagues, I think it's a good point to start. And this Docomo Cube calls for increase on required performance in 3 dimensions: the spectrum efficiency, the spectrum extension, where we include millimeter waves, and the spectrum aggregation, and network densification, cloud RAN, small cells. If you look to the projects, the 20 projects that we have running on the cluster, we are addressing all the dimensions of this cube, working together on the increase of capacity. So these are the projects that are, let's say, on the ignition phase of 5G. Okay? And I think we can also learn with these projects, with their experience, with their test beds, in this process to build up a European 5G vision. So recently we launched a survey inside the RAS cluster projects and asked the projects about their priorities in terms of research for 5G. And of course there are some, I'd say, good consensus that millimeter waves, new waveforms, device-to-device, cloud RAN, spectrum sharing are aspects that should be part of the 5G radio access technologies in order to allow the 1000 improvement in capacity. Another kind of requirements are the heterogeneity of 5G. As you know, 5G will be heterogeneous, so there is a need of end-to-end heterogeneous facilities. An example is if I went to test 1 gigabit per second link between a mobile terminal that is an LT cell, and I went to test the connection to a visible light cell in another point, and in between I have millimeter waves backhaul and advanced optical core. It should be possible to test this scenario using black boxes in order to check the performance of the different models of the system, but with some kind of standardized interfaces between the black boxes that allows us to check the performance and detect the problems and the challenges. So heterogeneity in 5G is an important aspect that needs to be considered in experimentation of 5G, but also test beds for interdisciplinarity research. For instance, if you pick up EMF safety, we have to work on technology radio aspects, but also on health. Massive antenna arrays has also important issues related with thermodynamics and dissipation of heat. I don't know if now FIRE also address this kind of interdisciplinarity that may be part of 5G. So I did some homework and look at your FIRE portfolio, and I understood that, okay, our wireless technology is just part of the current portfolio, but correct me if I'm wrong, I didn't find, for instance, a millimeter waves test bed, or a visible light communications test bed, or a massive MIMO. So I think there is room here to increase these test bed facilities, because it doesn't mean that Europe doesn't have these test beds. Europe has, for instance, University of Lund, massive MIMO test beds. In Sealeti, you have millimeter waves test beds, but they are not so far part of FIRE. So if you look to the 5G PPP program, they have very ambitious KPIs, and of course we need test beds to demonstrate the achievements to validate these KPIs. So in the RAS cluster, we consider that there is a lack of test beds for testing emerging 5G concepts to allow end-to-end and heterogeneity experimentation. And also, in terms of relation between FIRE and 5GPP, we have also considered that we have two different models. I consider that 5GPP is more mature than FIRE. FIRE initiative is driven by research, and therefore more open and more forward-looking than 5GPP roadmap. Usually FIRE target are SMEs and research centers, universities that cannot afford large-scale test beds. On the other hand, 5GPP is driven by industry, business objectives, and market case. So these are different that we have to understand and consider. And I think FIRE cannot and should not compete with in-house and mature demos developed by large industry. I think the role of FIRE is not compete with in-house Ericsson millimeter wave test bed. I think it should be open, allowed research from Europe to test ideas on top of these facilities. But I think there is room for cooperation between FIRE and 5GPP. Tools developed in FIRE can be very useful for the federation of 5GPP heterogeneous test beds. And for instance, the work that you have been done in FED for FIRE is very interesting, and I think it will be reused in the context of 5GPP. The issue here is that FED for FIRE will end in October 2016, and the program of 5G runs until 2020, so this is a question that needs to be addressed. But I think start from scratch is not an approach. Cooperation between FIRE and 5GPP, if you look to the heterogeneity of 5G, I think this is also an opportunity for joint experimentation. I know there is a FIRE project called FLEX, working on 5G elements. Why not combine these 5G elements with 5G elements from 5GPP? But the challenge is always to go beyond the border of projects. I have been coordinator of projects, and in the cluster is very challenging to put projects working together. Maybe open calls is the issue, is a solution, but I think it needs to be discussed. Also, maybe FIRE tools can facilitate the handover between the 5GPP phases. You have 3 phases, and I have, let's say, some concerns between the handover between this basic research to system optimization to large-scale trials. Maybe FHIR can bring a data set, a database for storage information from the previous phase to facilitate the link between the three phases. And the cooperation, international cooperation, I see this as a common objective between FHIR and 5GPP. Here I'd like to leave an idea regarding the millimeter waves and the propagation model. I think it's an opportunity for global collaboration on channel modeling between 5G initiatives across the world. It's very complex to have a good millimeter waves because you have to address propagation model because you have to address a lot of scenarios, a lot of bands, and this needs cooperation around the world. You need the Japanese colleagues, the US colleagues from China, from Korea. You may remember the Okumura-Atta model from the old times. I think here is a good opportunity for joint cooperation in the global scale. And maybe 5 tools can be very interesting to build up this joint database for measurements conducted in different regions of the globe. Okay, with this I conclude. Thank you very much.
Okay. Thank you very much, Paolo. I mean, there are already, you have triggered, I think, already a number of questions and proposals in your presentation. Is there any question at this stage to Paolo? I mean, he raised a number of issues. Does someone want to comment? No? Okay, so we'll go to the second presentation, which actually is a presentation from an industry, from an industrial organization. So Maurizio Cecchi from Telecom Italia is going to talk about an example of 5G program, what requirements with respect to 5G test experiments. So Maurizio has been responsible for collaborative research in Telecom Italia since 2001. So he's currently coordinating the Future Internet PPP Sci-Fi project, providing capacity building to the FHIR offer through a federation of infrastructures and associated tools. He has a degree in economics and commerce from the University of Genova and an MBA from University of California at Riverside. So let's continue. Thank you.
Let's see if something strange.
Yes?
Something on John. Yeah. Chuck, do you have the PowerPoint statistics?
It's there.
Yeah, it's no, it's not good. It's
Okay.
No, I can't read it.
No, it's there. Number 2.
No, it's broken. No.
Change it into a PPT because I put PPTX, maybe it's a PPT.
Okay. Yeah.
Do it here, do it here.
Yeah, I cannot.
Yes, yes, you can. It's, no?
It's because it's hides the I can fix it.
Have it here.
Maybe if you have 1 second.
Just 1 second now.
Yeah, better start from your laptop. We can always switch.
So why doesn't see the sign? Okay, view is full screen. Okay, sorry for the delay. So good morning to everybody. Thank you, Jacques. Thank you, Stefan, for the help. What I'm just talking about, what
talk about requirements from industry, about industrial testing. So the need to have a common experimental facilities, but really focus on the need of industrial products. So of course we know very well the requirements coming from the telcos industry, but these have been discussed a lot in the frame of network and especially on the 5G association. Because in this case, having a testing, a framework for industrial testing is extremely challenging because on one side, as we heard from Paolo, but is well known, we have a very challenging technical requirements. As you know, the KPIs for the 5G PPP at a very high level. And on the other side, we have a very fragmented situation of testing facilities in the major telco industries and vendor industries. So we tried to discuss this in the frame of a more wide ideas on 5G experimental facilities. I know that some of you in this room participated on the building of a white paper on 5G experimental facilities. There is a draft ongoing in the communities, especially in Network, edited by my colleague Antonio Manzalini and Professor Verdoni, with the contribution Professor Tafazzoli and many others, about the main vision about European experimental facilities in the 5G domain, and also an analysis on who they are at the moment. And of course, at the end, the general requirements are the same that had been addressed in many other previous 5 exercises. So we need flexible, large-scale framework. We really believe that to match these high-stake requirements, we need to go with exploiting SDN and FEN technologies. So it means work less with hardware, with direct text of hardware, trying to virtualize as much as possible the testing procedure that we are using in our industries. And of course, try to cope with the fragmentation that I mentioned before on industrial testing facility. Of course, we should not start from scratch. We know very good initiative, all the projects that have been presented, Fed for Fire. There are other exercises done in other public-private partnership like SciFi that I'm coordinating. So there are a lot of experience, and we should not neglect this experience, but now we have to have really another step forward toward industrial requirements. And so we need at the end to have a better architectural integration of the different components that are utilized in experimental, in industrial testing facilities. So, but we have to do this not in terms of technical solution, but in terms of competitiveness of our industries. Basically, the competition is not based on having ideas 3, 4, 5 years before the competitor, but to manage to be competitive in economic terms with the international competition. As you know, many investments nowadays are based on cost saving. So cost reduction is something in the mind of all our CEOs, both on the telco side, both on the vendor side. So we have to conceive something that helps really to cover also this part of the strategy. So what we have to do is to use the capacity, the capabilities that we have, the new technology. It's not the case that I mentioned SDN and MPV, to reduce the cost of testing, to share investment, so the risk in testing labs that are very expensive, so we have to share the cost, and help to avoid obsolescence through, I mean, a cross-use of testing facilities. This is not easy. As we said, there are scattered facilities around Europe. There is a barrier on management of know-how. That here there is an interesting aspect because the vendor side have a much more stringent problem in dealing with collaborative testing action, because when different actors, vendors, are doing testing of their new products in a collaborative environment, they fear the risk that other competitors could have a privileged knowledge on their offer. So how to manage this is extremely critical, but there are, I mean, solution models to deal with this. Probably on the telco side, this has been discussed in ETNO, that is the Telecommunication Association. There is less stringent requirements. So knowledge sharing, knowledge and IPR strategies are important, but are less critical in respect to the vendor side. And then on the other side, there is another economic factor, the trade-off of what you put in one, let's say, federated network of testing facilities and what you get it. From the public sector is a kind of must, is a general policy to help all your environment, your users, the communities in an international domain. But when you have to use labs that are extremely expensive, then the decision maker needs to know, okay, I'm putting equipment, hardware, organization, valuable tens of millions of euros in something that is shared or partially shared with the other. On the other side, the decision maker needs to know, okay, but what we are getting from this? In the market, this is done by common billing system. Of course, in very wide European network, this is impossible. So the economics behind this trade-off of what you are putting and what is the benefit that in economic terms is going back to the industry is an extremely important issue. So our idea is to build, of course, this from the first phases of the 5G program. Define, implement reference test environment, define, assess and usage, building trust-enhancing capabilities, and at the end build this value system in this federated environment that can support the whole system and find this economic consensus on what to do. And the best way is to do as a cross-activity in the new program. So at the end, it's important for the industry that this is cost-effective, so doesn't need to deploy new extensive infrastructure, so that is able to involve year after year new infrastructure, so the federation, the common framework, the glue of this initiative should enable then the entry of newcomer in the different phases, should leverage on the industrial investment, but also on public infrastructure. We know that in the academic area there are many good testing labs, testing of industrial products, so we must be able to involve them, to have the possibility to increase the size of these environments, have the possibility of the reuse of existing infrastructure. Of course, we don't have to build on the basis of new investments, and sharing for the infrastructure in this competitive environment. So basically, these are the main ideas that has long been discussed in all these 5G industrial forums. And so we're ready then to contribute to have it real happen in the next programs.
Thank you, Mauricio. We may have time for one question, if there is some urgent question. No? Okay, thank you. If no, we are now moving to our Okay, so our next speaker is Jacques Magan. He is the founder and chairman of Inter-Inov, a consultancy company specialized in public affairs and international innovation. He has 25 years of experience in international public affairs and research and development innovation in Europe, more specifically in the IoT domain. Jacques is a member of the board of the 5G Infrastructure Association and of the steering board of the Network 2020 European Technology Platform. He has been involved in FIRE for a few years in the coordination and support and in the FIRE board. So please, the floor is yours.
So thank you very much. So yes, I appear with another hat, somewhat. I asked my colleagues in the 5G Infrastructure Association board if they could come, but unfortunately they were not available, so I have to give that presentation on behalf of the 5G Infrastructure Association. So you've heard already in the first two presentations a lot about the 5G PPP. So my purpose with this short presentation, is not really to go into details. You can have a look at the slides afterwards. So I will go quite briefly, at least for those of you who are not yet familiar with the 5G Public-Private Partnership and the 5G Association, to give you a flavor of what this is about. Okay, all the details, of course, are then available. So basically, the 5G Public-Private Partnership is a new instrument in Horizon 2020. It is starting now. The first call has a deadline in November 25th. So it is really starting, but somewhat it is already an old story because it started a year and a half, 2 years ago already, with industry and commission trying to work together in starting this PPP. So this slide is just to remind you, all this story. So it is at the same time a new PPP with new projects which are going to be launched, but it is also something that have been already being discussed for a while. So you've already seen that on Maurizio's and Paolo's slides. There are very ambitious challenges for this program. So these are the high-level KPIs for the entire program. That means that each and every project somewhat shall show how they contribute to at least some of these challenges. How do they help the program as a whole reach these KPIs? Okay, so this is really the spirit. The spirit is that, of course, each and every project is going to contribute on its part. Okay, but at the same time, they shall show how they contribute to the challenges of the program as a whole. All right, so this is what this is showing. Basically, this is a detailed time plan. What we shall remember is that it is going to be there's going to be 3 or 4 phases. There are still some discussions, as I understood from last week's discussion. So the first phase is what is called the exploratory phase, the research phase. What needs to be done for 5G, to work on 5G technologies that will then be exploited and deployed. Okay, the second phase is more what is called system optimization. Okay, basically the research is, I would say, has progressed, and how do we go to the system level? And actually, from what I understand from the discussions that are happening today, it is a little bit more in this phase, in the system optimization, and then in the next phase, which is going to go into large-scale deployment and exploitation, that the 5G PPP people see the role of the facilities, of the test beds that could come also from FIRE. I have been trying with others. We have been giving presentations at the different 5G information days, and we have been trying to tell the 5G PPP people, the ones preparing the project, that they can use FIRE facilities also in the first phase. okay? Because if they miss that opportunity, then it is going to become more difficult to use it in the next phases, okay? So this is the message that we are sending and that we are repeatedly sending. So if you are running test beds and facilities that could be used for 5G, I mean, you should be already in the first projects in 5G PPP. Okay, this is the governance model. There is basically, I mean, I'm not going to enter into details, but there is a 5G Infrastructure Association, which is a legal entity which has signed a contract with the European Commission to achieve a number of things together, okay? And there will be some kind of interaction with the 5G PPP projects that will be launched, hopefully somewhere in Q1 or Q2 next year. There is also a relationship with the Communications and Networks-Oriented European Technology Platform, which is called Network 2020. Once again, I'm not going to enter into details, but basically the new thing is that there is a legal entity representing the private side, which is the 5G Infrastructure Association, who has signed a contract with the Commission for achieving a number of targets related to the 5G PPP. So these are the members of the association. There's industry, represented research, and also a few SMEs. Okay. So this is a reminder for the first goal, but those of you interested probably already know that, so I am not going to spend time on that. Very quickly, the 5G Association has put together a kind of a model that they believe would make sense at program level. So that means to achieve the different challenges that have been described, they believe that the different projects need to somewhat be structured. So they put together what they call strands. There are 4 of them, which are described here, okay? And within each of the strands, they think that a number of different projects shall be launched, okay? So these projects are basically described in a document which is called pre-structuring model. This is the picture, the overall picture, and there is basically a one-page description for each of these projects. Of course, we don't know the outcome of the call, and we don't know whether the different projects are going to follow this structure. But it was seen as important from the industry standpoint to show that there was a model that could help achieve the overall objectives of the PPP. So this is briefly the idea. If you have any more questions concerning the 5G PPP, you can go and look at the 5G PPP website. Thank you. So now I'm changing hats, coming back to the fire. So I would like to introduce our next speaker, who is going to talk about wireless technologies and networks in fire. Ingrid Moorman is a staff member of IBCN, Internet-Based Communications Network and Services, a research group at Ghent Universities and iMinds. She is leading the research on mobile and wireless networking, and she has a long-standing experience in running national and EU research-funded projects. Being the only female member, I wouldn't talk about long-standing experience. This is your words. Huh? At the European level, Ingrid is in particular very active in fire, where she is coordinating the CREW project, and soon also the Fire Plus Wishful project, and she also participates in Fed for Fire, Evarilos, Forge, and Flex.
Okay, thank you for the introduction. So I'm here with my head of CREW for this presentation. And for those who are not so familiar with CREW, I will give a very quick introduction on CREW. So in CREW, we have federated several wireless testbeds. For example, the iMinds testbed in Ghent, which offers heterogeneous ISM technologies. We have a wireless sensor testbed in Berlin. We have a TV band testbed in Dublin. Another testbed on LTE Advanced in Dresden. And we have an ISM TV white spaces testbed in Ljubljana at GSI. And so these are 5 different test beds that were not open at the start of the CREW project, but that we have now opened and can be used by anyone who is interested to use the facilities. In addition, on top of these existing test beds, we also have deployed cognitive radio hardware, for example, IMAX spectrum sensing agent in iMinds. We have Iris software, modular software radio platform. We have multi-antenna LTE detection from Thales, and we also have transceiver facility at API according to the standard in Wireless Innovation Forum. And so, as I said, these testbeds are now open for experimentation. So we offer different wireless technologies in different spectral bands. These testbeds are major. We also have methodologies and tools for experimentation. We offer reproducible test conditions, which is very important for wireless experimentation. And we have expertise from the lower levels up to the application layer. We also offer a portal with very detailed information, guidelines, and all kinds of tutorials, information that is important when you want to use the testbeds. And also what we think is maybe even most important is that we offer technical support and assistance for people who want to use the testbed. So we offer trainings, and we offer basic support to startup experiments and also for guiding experiments. So that's just the overview, but I'm supposed to talk about 5G, and we already have many talks about 5G, and very often these things seem to focus on increasing the capacity, 1,000 times more capacity, which is of course very important. But what we think, and from a wireless experimentation point of view, what is very important is to deal with heterogeneity, because we think the future is wireless, but it's also very heterogeneous. Hardware will be heterogeneous, although we are now working on a very sophisticated radio platforms. But in the end, depending on the applications, if you also look at the Internet of Things, there will be always very different devices, ranging from powerful high-end devices to constrained low-end devices. There will be many technologies that will provide the capacity. Sorry. In different spectral bands, and also in new spectral bands. We will have licensed versus unlicensed technologies. Some of the technologies can offer very high bit rates, definitely the new radio interfaces that are going to be developed in 5G, but we still need low cost, low bit rate technologies as well. And also very an aspect of heterogeneity are the traffic demands. We can deal, the applications will require very, very different demands from the network. It's not only about data rate. In some cases, latency is important. Duty cycle can be important, where we have to deal with energy efficiency, or burstiness, or even reliability can be a very important aspect, for example, for Internet of Things applications, for example, in medical applications or manufacturing applications. We also believe the density of wireless devices is definitely increasing, and this trend will continue. So high density is another challenge we have to face. There will be a massive number of co-located devices in the future. And actually what we want to realize in 5G is deterministic wireless network, which is of course a huge challenge and maybe the holy grail, but still people expect from wireless connection, they actually expect wired behavior with similar performances, similar guarantees, and this for heterogeneous applications and heterogeneous devices. And in order to realize this vision, we think that flexibility is key. Flexibility in terms of radio hardware, but not only the hardware is important, also the software that helps to exploit the flexibility of the radio hardware. And in addition, we also need intelligent mechanisms for dealing with all these heterogeneous hardware and technologies, for sharing the resources in a more efficient way. Another thing, again, from a wireless experimentation point of view, it is of course very important that we do not only develop theoretical concepts, but we also have to validate these new concepts. And in this end, you need experimentation. And in order to facilitate experimentation, we have to reduce the threshold for experimentation. And so now I will zoom in a little bit. First, flexible radio hardware. At this moment, a lot of flexible hardware is already available. It could be more sophisticated software-defined radio platforms, like, for example, USRP or WARP. It could be off-the-shelf radio chips with flexible radio control. We also have the possibility in Fire, in Crew, also OpenLab, I have to mention, to offer mobile nodes controlled by mobile robots. Many of these things are already available, and of course newer, more sophisticated hardware will come. In terms of software, we believe it is very important to have open software platforms that allow for flexible radio and flexible network control. So keyword there is that reconfigurability, reprogrammability, and composability, meaning that at any time, on the fly, at runtime, without disrupting the system, you have to adapt to dynamic wireless environments, to different heterogeneous application needs. And to this end, it is important that we use easy and well documented software abstractions, so that even developers of applications don't be the technical skills of the underlying hardware or networking. And so this is what we call, it's actually network stack softwareization. Is actually extending the paradigm of software-defined networking up to the very low layers, up to the physical layer of radios. And also important in terms of wireless experimentation, a wireless testbed should be evolving. Today, in a testbed, of course, we can only use hardware that is available and that is sufficiently mature and stable. Otherwise, nobody will be interested to use the hardware. But new hardware will come, so we have to adapt to that. There will be, in particular in 5G, it will be interesting to have hardware that also covers the new spectral bands that will be introduced, like the millimeter wave. As I said earlier, it is important to have hardware and software support. It is not enough to only provide hardware, but you also have to provide the software. And you have to be able to offer high-density scenarios with mobile nodes and very heterogeneous scenarios where different technologies have to share the wireless medium. I will wrap up because I think this is my last slide. So we see experiments as a service, and to this end, the testbed interoperability, like the mechanisms that are offered by Fed4Fire, are very important. Maybe one thing I still want to mention is that it could be interesting to not only have the fixed wireless facilities, but also portable testbeds that can be deployed at any location, so that you can also do tests in real-world environments with real-world users. And this last aspect I already mentioned, it is very important to reduce the cost of learning. And I think I could stop here. I will just put up my last slide, but I won't say anything about that. I just want to show that these are examples of the kind of experiments that are already happening today in the Crew project, in other Fire projects. So we believe that Fire can offer the key enablers for validating innovative 5G concepts. So I stop here.
Okay, thank you very much, Ingrid. So We've heard a lot in the previous presentation about the fact that 5G is going to be heterogeneous. We talked about interoperability. So I guess that the last presentation, which is going to focus on federation of testbeds and tools, is exactly one of the means to achieve some of these things. So the presentation will be given by Tim Wouters, who received his PhD degree in electrotechnical engineering at Ghent University. He is now active as a postdoctoral researcher at iMinds, and he focuses his research interest on network and service architectures and management solutions for scalable multimedia delivery. In FIRE, he is actively involved in projects building experimental facilities such as Bonfire, focusing on cloud services, and Fed for Fire, Federation of Testbeds.
Thank you, Jacques. Thanks. So in this presentation I will talk about the Fed for Fire project and give some more details about what the project is about. So it's an IP project coordinated by iMinds, trying to federate different testbeds developed earlier within the FIRE concept. Currently, so the project started in 2012, so we are starting our last year of development at this point. So it's the third cycle of building the architecture, upgrading the architecture based on the requirements that we got from the different experiments that already were ongoing on our integrated federated platform. Currently we have 28 partners, but we are at this moment in the process of including 14 other partners, 9 experimenters and 5 testbed providers, which should be included by the end of the year. So a picture that we saw already is I have a pop-up screen here, but okay. I will use the arrows and it works. So this is a slide that Hans also showed already. So this is showing the role of Fed for Fire in the FIRE concept. The goal of Fed for Fire is to federate testbeds, to make it available to users coming from the experimentally driven research project, but also individual researchers, industry and SMEs coming to Fed for Fire to open calls. We have already had 2 open calls for industry, but also smaller SME open calls, through which both experimenters and new testbeds can be included into the federation. This is an overview of the different objectives. So it's creating a federation framework for the upcoming research, future internet research, and also newly developed experimental facilities. The goal is to have these testbeds adopted as widely as possible by different communities, so not only experimentation facilities, but also experimenters coming from academia, industry, and SMEs. The goal is also to provide powerful tools to help the experimenters with lifecycle management. So what you see at the right is an overview of an experimenter lifecycle. First going to discovery of resources by searching based on its requirements, by reserving resources and provisioning them in the different testbeds. So for that we try to offer an API so that on each of the different testbeds you can use the same API to do this discovery, reservation and provisioning. But also having experiment control, so we have tools and APIs for experiment control. We have monitoring of the resources available on the different researchers through OML, and also permanent storage available from all the testbeds to a central location, which is upcoming. Also, we try to support key aspects like trustworthiness, to have a federated identity management so that people can log in to the different testbeds with only one account and not having the hassle of having different passwords to each of the testbeds, to have access control, accountability, and also SLA management so that we can have different service levels to different kinds of experimenters that each have different needs on the testbeds. When we look at what is currently available in the Federation, we have close to 20 testbeds. So what you see here is an overview. We have testbeds related to cloud computing, for example, the Bonfire testbed, which is composed of sites in EPCC, in INRIA with the Grid 5000 testbeds, and with the virtual wall in iMines. There are also LTE-based platforms such as the Physical Playground, also the Malaga LTE Performance Lab. We have SDN OpenFlow-based testbeds like the islands in University of Bristol, in I2CAT, and also at the virtual wall. But there's also the Korea Coran testbed with a distributed OpenFlow network available there. There are also wireless test facilities at iMines in the Norbit testbed in Sydney, and also in Greece with the NITOS and NetMo testbeds. In iMines there's also IoT capabilities, which can also be found in the Smart Santander, Smart City. And further on we have the also wireless community networking testbed in the UPC Community Lab, and there are also optical access testbeds in Madrid and in Stanford. Of course, at the moment, 5 more testbeds are being federated. They're going through the inclusion process at the moment. So this is the overview of the current of a bit more than 20 testbeds that are or will be integrated at the moment. When we look at connectivity, we have noticed from the requirements of the different experiments that it's important to have interconnectivity between the different testbeds, not only through a best effort internet connection, but also we looked into static VLANs, which are at the moment available between some of the testbeds. Also, Autobahn is looked into as a possible interconnection of controlled on-demand bandwidth between the European testbeds. Similar static VLANs are available in the US, for example, in the Genie Federation, and we also interconnected both the Genie and the FET4FIRE Federation through static VLANs that can be set up dynamically using a stitching engine that we have developed. What is also part of the offering is, of course, experimenter and testbed tools, so that a uniform set of tools can be used over the different federated testbeds by the experimenters. So what you see here is, for example, the MySlice plugin in the portal, which can be used for resource management. The OMF framework, which can be used for experiment control. OML can be used for the monitoring of the facility and of the different experimenter metrics that can be defined in the OML framework. NIPI, for example, is also a tool that can be used for experiment control. To the right, you see a screenshot of also a resource management tool, JFET, which can be used to build topologies in a graphical way based on RSpecs, which is a definition of resources from each of the testbeds that are integrated in this tool. There are also testbed-related tools. For example, the one at the bottom is the first-level support monitoring tool, where you can see as an experimenter what the status is of the different available resources in each of the testbeds, if all the services are alive, etc. And then there's, for example, also the PDP, which is used for security in the communication between the resources on the different testbeds. So this is an overview of the experimenters and testbed tools that are currently available and being developed in the last cycle of the project. And when we look at opportunities for collaboration, this is what is currently feasible within the FET4FIRE project. So we have accepted already 21 experiments from 2 generic open calls for industry, SMEs, and academics combined, and also from 1 open call that was specifically focused on SMEs. Currently there is an open call for SME running, so by the end of October this one will close, so we still welcome SME applications for experiments there. and 2 more SME open calls will be to come in 2015, so in the next year. A comment that was already made this morning as well was that for SMEs it might be not straightforward to use FHIR facilities, so we introduced the concept of having patrons in Fed4Fire, which means that the main testbed provider that is used by the SME can be contacted already during proposal phase through one of the patrons, which is one of the partners in Fed4Fire that will be helping the SMEs in terms of feasibility of the proposal and in terms of translating the idea from the SME concept into what is feasible as an experiment on one of the FHIR facilities in Fed4Fire. Another point, another means of access that will be open soon, by the end of this year hopefully, is the open access. So this is not funded, but it's not a funded mechanism, but it will open up the facility like is already available on some of the FHIR testbeds individually by the end of the year to interested parties. And then of course there was also already the question from what will be sustainable and what will be the access during sustainability phase. We have one last year of developments coming up and then 1 year of sustainability phase, and then afterwards there will be hopefully some kind of prolongation of the concept of the federation, where at least the existing software and existing documentation will be kept alive, and opportunities for new experimenters and testbeds to join the federation will be available. So thank you. This was a first overview of the Fed4Fire Federation concept.
Thank you very much. Okay, now we open the discussion, the panel, and we have prepared some slides to trigger the discussion. It's just 3 questions, I guess. If we can help.
Yes, maybe just before we launch the 3 questions, I have questions for Tim. You presented the offer from Fed4Fire. What about 5G in all that? I mean, how do you see either Fed4Fire evolve, I mean Fed4Fire or the Federation of testbeds evolve to cope with the potential requirements from 5G that were discussed a little bit before in the previous presentation? I mean, what is for you the main challenge or the main challenges that Fed4Fire and or Federation of testbeds would face, you know, to answer 5G requirements?
Yeah, thanks. Part of the question is, of course, what are the offerings from the current testbeds? Well, there should be a constant evolution, because the offering of the current testbeds are FHIR testbeds that were developed in the last few years. So indeed, there will be novel requirements coming up for new testbeds to be added to the federation for the upcoming years, going to Horizon 2020. So I think there will probably be a need for new testbeds and technologies to be included from IoT, from smart cities. Also, what we currently have, many of the testbeds are infrastructure related, and so there each of the resources are reachable individually. But a new trend coming up is that more of the testbeds will also be offering services where there is no specific need for experimenters to go into the details of the actual hardware resources. And so inclusion of more service-oriented testbeds, for example, related to big data services, that is also currently lacking in the offering from the federation. So there's clearly a need for novel testbeds, novel technologies, and then of course upgrades of the federation platforms that we have to include those testbeds.
So we may move to the 3 questions that we have. We may move to the 3 questions that we have prepared for trigger this discussion. So the first question is about the 5G technical domains and what should be the priorities. I see here that in the 5G 5GPP program, there is some interest to have some early demonstration of 5G in Europe, because it's also good for marketing of European Union effort on 5G. So you have several radio access and spectrum aspects that could be addressed, but what are the priorities? What should be the first ones to be really the demo? This is the first question. Then the second is on 5GPP and FIRE. So 5GPP is driven by industry, FIRE is driven by research. They have different maturity models. As Mauricio told us, this could be challenging if you mean that you have to open industry test beds in East industry labs. So what are the role of FIRE on this? And the third question is about heterogeneity of 5G. As we all agree, 5G is going to be heterogeneous. So these open possibilities of cooperation between projects. But I always think it's quite challenging, and you have also to try to find ways to facilitate this. Okay, we have these three questions. We may start with a panel. If you want to pick up one question, Mauricio. Okay, your presentation was quite interesting on this aspect of the industry. You mentioned that industry spend a lot of money on labs, and for sure there are some concerns regarding IPR. You also mentioned that you have been working on some models that could be worked out to open this. Can you elaborate a little bit more about the role of industry and how this is related with FIRE?
Okay, first it's important to say that we don't have to start from scratch. So there have been a lot of collaboration with projects and people from FIRE initiative. We did some initial, let's say, exercise through the infrastructure for the public-private partnership on PPP together with iMinds and many other actors. So in terms of common understanding of what is needed, what is behind, there have been a lot of activity, but also a lot of learning for action mistakes, what have been done in terms also in IPR on how to deal with open source matters and so on. So first of all, we have to exploit this, but then what is missing is really the development of these economic models in which you can balance what are the inputs in common framework, in common federation, or however you want to call it, and the output of what is coming out. So the real understanding of the requirements in business terms, in economic terms, from the industry is really something that is missing. That are good, let's say, scientific economic model behind this, but we have to put it in place. I mean, work with them for a real initiative in Europe.
Somebody wants to raise a question, just to be free. Okay, regarding the priorities for 5G experimentation, I'd like to hear the Ingrid. She's an expert on radio access and testbeds. What do you think that Europe should put as a priority to show to the world that you are doing our role on the 5G?
Okay, I think I already addressed a bit in my presentation, but I think in the past we have been focusing more on the wireless infrastructure. And if we see the kind of questions we get from industry, from SME, and now I'm also speaking a bit from iMind's side, because we are collaborating a lot with industry. Offering just hardware is not enough, and industry, in particular SMEs, they are developing specific wireless solutions that require some guarantees from the network. And to this end, they want to do more with the radio than that what is offered by the standards today. Mm-hmm. And so what is missing a bit, and that's why I said it's not only the hardware that matters, but also the software. You need more flexible software architectures that can exploit much better the capabilities of the radio, because even in off-the-shelf chips like Wi-Fi or ZigBee, there are a lot of capabilities, but they are not supported today. And so by also focusing on the software and on the reconfigurability, and by adding intelligence, because it's not enough that you can configure the things, but you also have to, in terms of research, develop the strategies that can help to come to the most optimal settings of radio and network parameters. So I think this is also very important in terms of research, because capacity will come with more performant hardware, but you also need the means to exploit the capacity and to share the capacity in a very efficient way.
Okay, good. And Jacques, you have a view of priorities for experimentation in 5G?
Well, actually, I will answer in a slightly different manner. I was listening to Tim, and what I understood, and this is a little bit what Ingrid is saying, is that we need to understand what the requirements are, and then we can respond. If we look at the 5G landscape as a whole, this may work. But if we look at the potential interaction between Fire and the 5G PPP, I don't think this will work. We cannot wait. We have somewhat to try and start answering before the question is on the table. Because if we wait for the requirements to be expressed, it's going to be too late. Because these people will have run their projects and they will go to the next stage already. So somewhat I see, I mean, you are talking about different maturity model. This is somewhat true in the sense that 5G PPP is more supposed to be more industry oriented and going a little bit shorter term somewhat. I mean, still looking at 2020 as an objective, which is okay. From some of your perspective might be short term, but still not too short. So I'm wondering, you know, how can we, from the testbed side, from a federation of facilities, from the Fire perspective as a whole, how can we try to to prepare the testbeds so that we can, or at least prepare the ideas that we would like to develop in parallel to having the 5G PPP projects run, and maybe be also a partner of these projects. This is really, I think, because this would make things easier somewhat. You know, as it was mentioned in one of the presentations, that it's not so easy to have interaction between projects. I think, Paolo, you mentioned that as the RAS cluster, you know, you know that. So I agree with that. I think the best way is to be a partner in the same project. So how can we achieve that? You know, in the preparation phase, you know, and in the preparation phase, the requirements are not known yet somewhat, because the requirements are usually part of the project. So this is this you know, ambiguity that I think we really need to solve, because otherwise we will always be on the Fire side lagging behind from the 5G PPP perspective, once again, not the 5G as a whole.
A very interesting comment. I also think that it's challenging to put projects cooperating, even if there are, here is even harder because you have projects from Fire and from projects that are not from Fire, from 5GPP, and this is also I found this very, very challenging. Okay, but we have here these two trends, let's say, experimentation done by industry and experimentation done by research. I would say maybe that the industry is more willing to have demonstrators able to show to their clients that they have solutions, 5G solutions ready, which is different than the Fire perspective, where open test beds for experimenters and SMEs develop their solutions on top. And I think we should find a balance here between these two goals, between demonstrators, closed demonstrators, and open experimentation. And I don't know inside 5GPP what are the current discussions on this, but Maurizio, for instance, do you consider that in 5GPP a model like open calls where others can develop experiments on top of 5GPP testbeds?
Yes, this is something discussed, but for the first, This has been discussed up to now inside the different proposals. So the different groups that are building initiative, as you know, in this pre-structured model presented by Jacques. So at present is a freedom of each proposal to use this tool or not. And personally, I think that it would be an extremely, useful tool to do it. Has not been, introduced in terms of program in the whole work plan. So we have the freedom to decide or not. My, vision is in the second work plan of the 5G PPP that will be more devoted to experimental facilities in a wider scale. This tool will be utilized and envisaged by the European Commission, but of course I'm not the European Commission, there are other people there, but I think that could be extremely useful, as has been useful in the FIRE program.
Yes, I also consider that this open call mechanism is very interesting because it's quite a short project. We don't have so many mechanisms to develop short projects in Europe. So you spend 1 year with a test bed, and you are committed to deliverable after 1 year. I think this should be kept, and if 5GPP will address this, is also, I think, a good idea. Okay, we have still time for questions from the audience. Please. No questions? Okay, let's see if I can also have an issue regarding industry in the research. I see industry very focused on LTE. Okay, that everything is LTE. LTE advanced so in the 3GPP roadmap. Okay, and I see Wi-Fi and wireless bands that are not regulated, and licensed bands and so on, a more innovative ecosystem. Okay? And also, in terms of experimentation facilities, should we put priorities on the 3GPP roadmap, like the follow-up of LTE, release 12, release 13, or should we exploit other ways, maybe more innovative? How do you see this? Should be everything put on 3GPP, or should we be let's say, room for other ideas that are not on the 3GPP roadmap? Maybe Ingrid.
Yeah, well, I should say I'm not sure if industry is mainly interested in LTE. This is not so much our experience. Of course, there is a great interest, but still for many innovative solutions, industry prefers to use non-licensed services because in some applications they cannot afford to charge for the service. And while to be honest, a few years ago we thought, okay, Wi-Fi is major and it's the end and there will be further evolution and that's it. But now during the past year we get a lot of questions for people that still have an interest to use Wi-Fi and to optimize and tune and tweak Wi-Fi because they believe they can get a lot out of Wi-Fi, or they are interested in LTE but are exploring how can you use it in unlicensed band. This is something which is now coming up. So I think, yeah, in terms of technology, I think it's definitely a very interesting technology because it's a spectral efficient technology. But I still, heterogeneity is key, and I think we should not focus on one technology because different applications require different needs also in terms of technology.
Somebody else wants to comment on this? No? Okay, good question. You have a question, please.
So a lot of your questions are about the relationship between research and industry and their different requirements. I'm very interested to understand whether you have explored any pathways for taking ideas and technology innovation into market that could incorporate both fire and industrial test beds in some sort of pipeline or pathway to the new product and service, because it may not be a case of one or the other. It may be a sort of staged approach as you take something to market.
Yes, the issue I think is the instrument, because you have fire instrument and we have 5GPP instrument. So we may try to, with the instruments that we have, to develop this kind of approach that you mentioned. I also agree that is important.
Yes, if I may, this may be the start of a response to my question earlier, because what I hear from the others and what I heard already from in the 5G PPP context was that maybe a lot of people are thinking of using some facilities maybe more in stage 2 for the system optimization, the trials, rather than stage 1. That means that somewhat, if we want to think about what you are suggesting, we have basically 1 year, 1 year and a half to start and considering such a pathway that we could then present from the FIRE perspective at least, or having a, I don't know, joint working group with the 5G PPP people. You know, that is something that we could start working on with them to say, okay, you are doing phase 1, some research on the 5G technologies, you are considering a number of potential trials for the second stage. You know, how do we need to have FIRE match these requirements? And that would also, you know, respond to the question I was asking to Tim. Like we cannot wait for the requirements and then come up with a test, but that's not going to work. We need to work together somewhat. So.
Stages, but from what you've just said in that sentence, but FIRE is stage 1. FIRE is not really stage 2 in my view. So I'm wondering why we're focusing on supporting stage 2, and if we are, we're going to be changing what FIRE is.
No, I'm not saying we are from the FIRE side. What I'm saying is that it looks like this is the feeling the people have. Okay, the people in the 5G PPP context. I mean, the people, the feeling they have, and it was already reminded by a couple of the speakers, is that the feeling they have is that the FIRE facilities and the testbed facilities in general shall be better or more efficiently used in stage 2, which, by the way, is not yet the large-scale trials, which is phase 3, which is what is called at this stage system optimization. Okay, so somewhat it's not. I would agree with you that it's not. I mean, FIRE doesn't really fit with the large-scale trials, but with system optimization, maybe better. So basically, I would encourage, I mean, all of us to try and work together and see what, you know, how we can go on with your suggestion in the next year and a half altogether.
We may have time for one question, so just to finalize the session, to end the session. No, if not, and we may close the session here. I'd like to thank all the speakers.